Hi, welcome to Dr. Raz, the Baking Chemist. So today's question is another one of those Born-Haber cycle questions. It's a year 2 question, but obviously you need to know your year 1 Hess's cycles and Hess's laws, etc. Okay, let's get down to it. Okay, so it says draw a fully labeled Born-Haber cycle for the formation, Born-Haber cycle for the formation of solid barium chloride. So this is barium chloride. And there's the formula. They've been kind enough to give us the formula, but sometimes they don't, from its elements. Include state symbols for all species involved. Okay, now, whenever I need to draw a Born-Haber cycle, I understand that, okay, two things. One, it says from elements, and second, it needs to have the final product, barium chloride. Now, I know that, well, this is how I do it, and this is how normal Born-Haber cycles are actually drawn. You start from elements, and because I know that most of the Born-Haber cycles, if I have my elements here and my product here, most of my Born-Haber cycle is going to go all the way up here. I actually leave plenty of space, okay? So, and I start from this side. So the first thing I'm going to do is, make sure you can see it from here possibly. Okay, so the first thing I do is I write down, you don't have to draw lines, but I write down the elements involved. Okay, so it's barium chloride, so it's obviously barium, so there's a line, you don't have to draw it, plus chlorine. All right, and then the product goes underneath usually it's exothermic, but not always. But anyway, we don't know that, so I'm always going to draw the final product here. So here we go. So this is, hope you can see it still. Yeah. So this is your final product. Now, obviously it says state symbols, so I'm going to start including state symbols right away. So barium is usually a solid. Okay, normal conditions, and chlorine is, as I'm sure you're aware, is usually a gas. Barium chloride is also a solid. It's an ionic product, so it's a solid. Okay, so that's that. Now, the next thing before I actually draw the Born-Haber cycle is I need to understand how many atoms, first of all, are involved in the product. So there's only one barium atom, so I only have one atom there. There are 2 chlorine atoms, so in a molecule of chlorine there are 2 atoms, so I don't do anything there. If you have a look at my previous Born-Haber cycle question that I've gone through, it's up here, you'll notice that I've had to change that. Okay, look at the Born-Haber cycle of magnesium oxide video, and you'll notice that I've had to change that. I'm actually not going to go into much depth for this Born-Haber cycle because I have done in my previous video, the magnesium oxide one. Okay, so I'm just going to continue to do it, but any sort of relevant points I'll mention. All right. Anyway, so the first thing is obviously the atoms, and now what I need to do is I need to change these elements. For the Born-Haber cycle, I need to change these elements so they are ready to form the ionic product. For that, I need to know, well, what's the charge on the barium? So in here, in this molecule, what's the charge on the barium? What's the charge on the chlorine? Now, if you cannot tell me what the charges are looking at an ionic compound, what have you been doing for the past 3 years? Okay, go back and learn ionic compounds. Okay, so looking at the ionic compound, I can tell that the charge on the barium is +2, and for each of the chlorines is -1, and that's why there are 2 chlorines. 2 times -1 is -2, +2 neutralize each other out. Okay, so I know that the barium needs to have a +2 for it to be ready to react, and chlorine needs to be a -1, but there needs to be 2 chlorines. Okay, let's do this. Now, everyone has their own sort of methodology of doing this. What I do is I try and deal with metals first, get them ready to react, and then I deal with non-metals. Okay, so this is how I do it. Other people have their own way of doing it. So some people just do the non-metal first and the metals, or they alternate. Okay, but I just like to, I like to be organized, and I just like to do one thing at a time and then do the other one. Okay, so the barium. Now it's a solid, okay? So the first thing that needs to happen, as I said, look at my previous video for the details, but the first thing that needs to happen is atomization of barium. So atomizing barium gives me, okay, barium gas. And of course, nothing happens to the chlorine because I'm not dealing with it yet. And that is fully labeled, remember, in the question. So enthalpy of atomization of barium. All right, that's that. Next thing that happens, and remember I can draw, these lines here, but I don't need to. Right, so now that I've got atomized, it's still not ready to react with chlorine yet. So what I need to do is I need to ionize it. Now, in other words, remove an electron. So first ionization energy. So the next thing I need to do is remove an electron from barium. And remember, state symbols. This is where most students lose marks because they miss out state symbols. And the question specifically states include state symbols for all species, yeah? So gas, and I guarantee you, I'm probably going to make a mistake, but I'm going to look over it at the end to make sure I'm not. And that's what you should be doing. Now the barium plus is lost an electron. This is another place where they make a mistake. Where's the electron gone? Well, nowhere for the time being. So you need to include that in this step. So there's my electron that's just been lost from the barium. Plus chlorine. Nothing's happened to that still. Okay, and that is delta H. Maybe I should be writing it there just to make it neat. But anyway, delta H, first ionization energy of barium. Okay, and then it's still not ready because remember what I said earlier on, barium needs to have 2 positive charges, right? So I need to lose a second electron. So the next one is barium. It's already lost 1 electron, so it's lost another one. Now here it already has a second electron. It's not gone anywhere yet. It's not reacted anywhere, so I need to include that. And plus it's lost a second electron, so it needs to have 2 electrons. Plus, and then nothing's happened to the chlorine. Still a gas. Okay, now state symbols for electrons, electrons, gases, whatever. You don't need to put state symbols for electrons. It's accepted. Okay, so don't worry about the state symbol for the electrons themselves. Yeah. Okay, now barium is ready to react. Okay, now I need to deal with chlorine because chlorine's not ready. And so the first thing I need to do is I need to atomize the chlorine. Okay, but remember I need to carry the barium on. Oh look, I've not done the step. I've not labeled this step. So this is delta H, second ionization energy of barium. Okay, now going back to that as well. So barium, nothing's happened to barium. It's ready to react. It's just waiting very patiently for the chlorine to get ready. Okay, and plus, and then what's happened to the chlorine? It's been atomized. So when you atomize it, now atomizing 1 chlorine molecule, again, look at my video, but atomizing 1 chlorine molecule gives me 2 atoms. Okay, enthalpy of atomization is well, I'll come to that in a second, but when you atomize a chlorine molecule, you actually get 2 chlorine atoms. And of course, there were gases already, but this continue to be gases. All right, and this is now here. I'm just looking to see if it says use information at all or not. No. Okay, so now do I label this enthalpy of atomization or bond enthalpy? Again, this is where your definition comes in. Your knowledge of the definitions. If you're not sure, you're going to mislabel it because enthalpy of atomization, the definition is the formation of 1 mole of an atom, gaseous atom, from its elements. If I atomize chlorine, what I should have is just 1 chlorine atom, but I've got 2. So it's not atomization that I'm doing, it's bond enthalpy. So I'm taking a molecule of chlorine and I'm splitting it in the middle. So I'm ending up with 2 chlorine atoms. So that's bond enthalpy. So here it's not enthalpy of atomization, it's bond enthalpy of what? Of chlorine. Okay, and this is gaseous. This is gaseous, this is gaseous because I'm ionizing gaseous, and this is solid. Okay, so that is bond enthalpy. If I am going to put, I can label it atomization, but if I do that, remember, enthalpy of atomization gives you 1 mole. But because I've got 2 moles, that means I need to have 2 times enthalpy of atomization. So I can label this, or sorry, not and, I can label this enthalpy of atomization. I'm sorry if this is making a bit mess, but I'm trying to explain. So enthalpy of atomization of chlorine, but this is going to be 2 times 2. Okay, so you need to be careful. You can label it, but make sure if it's enthalpy atomization, it's 2 times, but it's better just to say bond enthalpy. All right, you'll get the marks both ways as long as you mention the 2 times there. All right, okay, so now chlorine is still not ready. Why? It's just gaseous atoms, it's not ions yet. So what happens now is these atoms, remember, these are non-metals, so non-metals accept electrons, yeah? So guess what? Very fortuitously, electrons are there for it to accept, okay? Okay, so sorry about that. The camera just stopped working for some reason. So what I was saying was that these chlorines, these chlorine atoms are now ready to accept the 2 electrons. Okay, remember there are 2 chlorine atoms. Each one of them will accept 1 electron. Okay, so as I said, maybe you caught it or not, but as I said in my previous video, I explained that I'm now going to go down because electron affinity, which is the acceptance of an electron by a non-metal, is an exothermic process. The first one is anyway. So barium 2+ continues, all right, and then of course each of these chlorines will accept 2 electrons. I can do it in 2 steps, but I might as well just do it in 1 step, isn't it? Yeah. So each chlorine, remember, it's not chlorine CO2. It's each chlorine accepts 1 electron to give me 2 Cl minuses. Okay, and that means here the step is enthalpy of electron affinity of chlorine, but there is times 2. Yeah, because there are 2 electron affinities of chlorine. Okay, it's not a second electron affinity. Be careful, yeah, because it's not 1 chlorine accepting 2 electrons, yeah, one after the other. It's 2 separate chlorine atoms, each accepting 1 electron. Okay, so it's enthalpy, electron affinity of chlorine times 2. Okay, now barium is ready, chlorine is ready, and therefore they can now form a lattice to give you the final product, which is barium chloride, and that is the lattice enthalpy of barium chloride is solid. Okay, now just checking, look here, just checking, look, in my explanations I actually missed that step, and of course I would have lost a mark. Okay, so this step is going from there to there, and that is the enthalpy of formation of what? Barium chloride, and that's a solid. There you go. So the mark for this is probably going to be, that's a 9-marker question, so it's probably going to be about 6 marks here, and 7, 8, 9, probably 3 there. So it'll be 1 mark per step. So there's 1 mark, there's 1 mark, there, oops, sorry, there's 1 mark, there's 1 mark, 1, 2, 3, 4, 1, 2, 3, 4, there's 1 mark, and there's 1 mark, 1, 2, 3, 4, 5, 6. Okay. Okay, so that's that. So that is the first part, so 6 marks. Now, the second part of the question. Use your Born-Haber cycle and the standard enthalpy data given below to calculate a value for the electron affinity of chlorine. Okay, again, I've done this particular type of question in my first video, so have a look. I've done a very similar question. I'm probably, yeah, let's do this anyway. Okay, so it says use Born-Haber cycle and use your Born-Haber, so what we've drawn, and the standard enthalpy data given below to calculate value for the electron affinity of chlorine. Okay, so what you need to do is you just put a formula in. Remember, as I said before, enthalpy of formation, this is how I do it. Enthalpy of formation of barium chloride. So this is just a formula. The formula is that this equals all of that added together. All right, so equals, so enthalpy of atomization, okay, plus enthalpy of first ionization of barium plus enthalpy of second ionization of barium plus, I know the formula should all be in one line, but this is just not possible, plus second ionization of barium plus, now this is, I'm going to put down enthalpy of atomization. Now I need to have a look, have they given me bond enthalpy or enthalpy of atomization of chlorine? enthalpy of atomization of chlorine. So they've given me enthalpy of atomization. So in this formula, I'm going to have to put enthalpy of atomization, right? Not bond enthalpy. Even though here I'll get the mark, but if I put bond enthalpy here, I probably won't get the mark because the bond enthalpy information hasn't been given. All right, so here I'm going to have to put 2 times enthalpy of atomization of chlorine. Okay, plus, and here I'm going to say 2 times electron affinity of chlorine, and plus lattice enthalpy. Alright, now they want me to find electron affinity of chlorine, so obviously they want me to find that. So all I'm going to do is I'm going to rearrange that. Okay, now rather than rearranging it with all these values, you know, all these sort of letters, I might as well put the values in and then, you know, rearrange the numbers. I find it easier, but it's up to you. So I'm going to make that the subject of the formula. Okay, so all I'm going to do is enthalpy of formation of barium chloride. Have they given it formation of barium chloride? Yes, they've given it to me, minus 859. Minus 859 equals atomization of barium, yep, plus 182. Yeah, just follow these. Yeah, don't try and just copy that across because you don't know whether you've missed something or not. So I'm just going to literally follow my formula. First, ionization of energy of barium. First ionization enthalpy of barium is plus 503. Second ionization of barium is plus 965. And 2 times enthalpy of atomization of chlorine. So atomization of chlorine is plus 122, but I'm going to have to remember to do it now. Yeah, multiply by 2. And then, of course, there's 2 delta H chlorine, electron affinity, and then plus, last one, lattice enthalpy formation, minus 2056. Minus 2056. Okay, and now I just gotta move all the way. I mean, I can actually, let's just add the numbers and then I'll move it across. Yeah, so let's just do that now. Plus, remembering to multiply by 2 using the brackets. People use the brackets, that's what they're there for. Sometimes people just add, you know, do all these sort of multiplications and additions and subtraction without ever using brackets, which can cause serious problems. So which equals that. Minus 164. So that means minus 859 equals minus 164 plus that thing that we're trying to find out, electron affinity of chlorine. And now, of course, it's easy, isn't it? Yeah, just to move these around. Yeah, so I'm just going to move this around, leave that on this side, so making that subject of the formula. So minus 859 minus there, so it's going to become plus here, 164 equals, and of course it's going to be 2. All right, I'll deal with that 2 in a second. Electron affinity of chlorine, and of course that gives me, so that's minus 695, and of course I need to divide it by 2 to give me minus 347.5. Now I know they've not mentioned significant figures, right? But I'm a sort of a chemist, yeah, I like to do things properly. So what I'm going to do is I'm going to look at the kind of significant figures they've given me, and they've not actually said how many sig fig they want. Okay, so they've given me 3 sig fig, 3 sig fig, 3, yeah, 3, okay, there's 4 sig fig there as well. So I think I can probably leave it like that, you know, because that's 4 sig fig, or I can leave it 3, 4, 7, 3 sig fig, or, you know, or 3, sorry, not 3 sig fig isn't 3, 4, 7, it's 3, 4, 8, yeah, 0.5. So I can leave it 3, 4, 7, or I can leave it like that. Okay, I think I'm just going to leave it, and of course this is kilojoules per mole, they don't ask for units. So I'm going to leave it minus 348 kilojoules per mole. Okay, but you can leave it like that, okay, or you can leave it like that, it's not a problem. All right, because they're not mentioning significant figures, and they've given you 4 sig fig there, so you know I can include 4 sig fig. Okay, so that's the answer there. Okay, again, where students often go wrong, I mentioned some mistakes in my other video, Haber video, magnesium oxide, but I mean, one of the more common mistakes would be this, yeah, they would not realize that this is 2 times, you know, not a single electron affinity. They might miss out the 2 times there as well. Okay, so they might just put, you know, 122 instead of 2 times 122. So be careful. rearranging equations. Yeah, so some people struggle with rearranging equations, and so therefore, I mean, some people start doing this, hit this point, they'll say, all right, well, you know what, I'm going to move that across here and that across there. Well, hold on, the point is to have this expression on one side, whether it's on that side or that side, does it really matter, right? So it was on this side and it was positive, right? So I just left that side and moved the other thing across. Yeah, just be careful, and of course, don't forget silly mistakes on your calculators, right? Learn how to use a calculator. Okay, right, I think that's that. Now, the next question is an entropy question, and I think I'm going to do that next question, the entropy question, next week. Okay, this was just an enthalpy type question of barium chloride, all right? But this is leading on to the next question, because in the next question they said to use this data to work out entropy. Okay, so I'll do that next week. All right. I hope you found that useful. Please be careful with these Born-Haber cycles. There is a lot of scope for the things to go wrong. Yeah, so you know, be careful. State symbols, again, check, yeah, that you included all the state symbols everywhere. Yeah, you know, especially these things. And don't forget to, you know, include electrons that are given off. Here, of course, you're not including electrons because electrons have been taken up. And you should be okay. I mean, the marks, you know, so that's 6 marks over there. So here, yeah, I'm assuming that the marks, 1 mark would be for that, you know, formula. Another mark is for entering the values, and you know, the last mark would probably be for the answer. Yeah, and I think that last mark is taking into the 2 into account. Yeah, so dividing by 2. That's 6, 7, 8, 9, and that's a 9 mark. Okay, let me know how you get along. Try some of these questions. Remember, you got to do this under exam conditions. So you might think, yeah, I know how to do it. It's simple, isn't it? But try it and time yourself. Yeah. So this is a 9 marker. Try and do this, the whole of that in 9 marks without making a mistake. That's when you know, yeah, I've got it sussed. All right. Okay. Well, if there are any comments or suggestions, okay, put them in the comments section below, and I'll see you next week.